High above the Earth lies the International Space Station, the first microgravity laboratory for the whole world. Let's go there now to meet the host of our show, the robot who knows a lot, MC.
Hello, everybody. I'm MC the Robot. I see you made it to the International Space Station. Welcome. Oh, by the way, for you first-time space travelers, we're about 407 kilometers above the Earth. So don't look down if you're afraid of heights. Told you not to look down. Now that you're here, let's talk about the International Space Station. The space station is... What's that? You've never heard of a space station? Then let's take a look back into space station history.
Space Station History. The first recorded ideas for a space station surfaced in the late 1800s and early 1900s. It all seemed fanciful at the time. Humans living and working in space. Who would believe it? The 1950s, the space age has become a reality. Rocket scientist Wernher von Braun visualizes a wheel-shaped space station. Is this the shape of things to come? 1971, Russia launches the first space station, the Salyut 1. Space stations become a reality as cosmonauts live and work on board the craft. 1973, the United States launches its first space station, Skylab. Inside, astronauts conduct scientific experiments, study the Earth, and learn about the effects of weightlessness on the human body in space. 1986, Russia begins assembly on the space station Mir. Records are broken for long-term stays in space, and scientific research in orbit continues. 1995, the United States teams up with Russia, docking the space shuttle with the Mir for the first time, starting a new era of cooperation to prepare for the International Space Station.
Thanks for that great overview. Now, let me show you the latest and greatest in space stations, the International Space Station. Let's take a quick tour of the largest spacecraft ever built. The International Space Station is over 108 meters long. It's made up of many different modules of all shapes and sizes. When complete, the station can hold up to 7 people. It will have the same volume as the inside of 2 jumbo jets. Now, what do you suppose the astronauts can do with all that room?
Things to do with all the room on the station. A. Open a clothing store. B. Make a space restaurant. Or C. Conduct important scientific research in the microgravity of space. If you chose C, conduct important scientific research in the microgravity of space, you are correct.
That's right. Science is the main purpose for building a space station. Different crews live and work on board the station, conducting science experiments for months at a time. And since the station can stay in space for at least 10 years after it's complete, that's a lot of science. And remember, microgravity gives us a chance to study how liquids, metals, crystals, and even flames behave. This research is very important. It could lead to better computers, better fuels, and even better medicine. And since crews can stay on board the station for long periods of time, they can test the effects of microgravity on the human body. Something we need to know if we plan to travel long distances in space, like back to the moon, or even onto Mars. So now that you know why we need a space station, the next question is how to get it into space. Remember how we said the International Space Station is the largest spacecraft ever put into orbit? What's it going to take to lift it 407 kilometers above the Earth?
It's just too heavy.
The station is heavy. In fact, it weighs over 450,000 kilograms. No single rocket in existence can lift that. But if we take the station and separate it into pieces, then those pieces can be lifted into space. The different station parts are being made around the world. After all, we couldn't call it the International Space Station unless there were many countries involved with building it. That's right. You might call the space station a station of nations. Now let's take a quick look at what's going on around the world with just a few of the countries involved with the station and the parts they're building. Location, Russia. Some of the key station pieces are made here. This is the control module named Zarya, the Russian word for sunrise. It's the very first piece of the space station. If it looks pretty technical, that's because it is. It provides the early steering and power. It's launched into space on a Russian Proton rocket, like this. Location, USA. This piece is Node 1, named Unity. It's one of the smaller pieces of the station. At around 6.7 meters long, it's pretty big for being small. Unity earns its name because it's a connecting tunnel to other parts of the station. See how it has so many portholes? It was made in Huntsville, Alabama, then moved to the Kennedy Space Center in Florida for launch. Unity is carried up into orbit by the space shuttle, like this.
We interrupt this program for a special announcement. Please take out some paper and a pen. You might want to write this down. It takes 43 flights to launch all of the station pieces. That is all. We now return you to MC the Robot.
Yep, it takes a lot of flights to launch all of the pieces, and it also takes a lot of teamwork between the partners. Think about it. All of those countries working together to build one giant station, using teamwork. Teamwork. Teamwork.
All right, listen up. We're gonna build us an international space station, right?
Right!
But we're not gonna be able to do it with just one player. It's gonna take teamwork, right?
Right!
Each player has an important part to contribute on this team. We will succeed, but only if we play together. Okay, you know the plan. Let's hit the field.
And it's a great day to assemble a space station. And it looks like the Russians are hitting the field first with the control module, Zarya.
Let's get that control module up there, team.
Zarya's launched into space, and it looks like it's good! And here comes the space shuttle with the next component, Unity. Zarya is attached to Unity. Assembly is good!
Let's get those station pieces up there. Go, go, go. Move it, move it, move it.
The crowd is going wild as more station elements are added. We're seeing solar arrays, the Japanese experiment module, robot arms, lab modules, habitation modules, modules of all sizes and shapes. I've never seen an assembly sequence like it my entire career, ladies and gentlemen. One teamwork. One teamwork!
Yeah, it takes a lot of teamwork to build the station. But getting the station parts into space is only one part of the job. Once the station modules are in orbit, they need to be put together. The shuttle's robot arm is used for some of the bigger jobs of moving the giant parts into place. The space station has a robot arm of its own. It's made in Canada by the same people who made the shuttle arm. It has the ability to inchworm across the station from point to point. Neat, huh? After the robot arms have done their work, astronauts and cosmonauts do some of the more tricky jobs by hand, conducting over 1,000 hours of spacewalks to connect cables outside the station. Cables used for power, water, air, and communication. Similar work was done during the Hubble Space Telescope servicing mission, where astronauts worked with connectors. It's not easy to do in those thick spacesuit gloves. Astronauts train for many hours to do the job right, not just in space, but also underwater. Being underwater in a suit is a lot like working in space. At the Neutral Buoyancy Lab at the Johnson Space Center in Houston, Texas, astronauts rehearse putting the space station together in a 40-foot deep swimming pool. And once it's all built, how do you get power to the station? A long extension cord? Wrong! One answer is right above you, the sun. That's right. The sun provides a lot of the power used to run the experiments and equipment on board the station. This power is harnessed through solar arrays. There are 8 large solar arrays on the station, which equal 4 complete modules. Each one is over 74 meters long. Best of all, the station's solar arrays can actually turn in a complete circle, following the sun wherever it goes, getting the most power possible. Well, we're at the part of the show where it's time to review what we've learned about the space station. Shall we? The International Space Station is about 407 kilometers above the Earth. The station is a great place to conduct scientific research in space. The station is so big, no one rocket could launch it all at once.
All right, don't rub it in.
Sorry, it takes 43 flights to launch the station in pieces. The station is a team effort, with many countries working together to build different parts of the station. Astronauts assemble the station in space, using robots for the big jobs and doing the smaller, complicated work by hand during spacewalks. And finally, solar arrays play an important part in providing power for the station. In the coming years, be watching for the station to come together. It's going to be exciting. There's so much to know about the International Space Station, it can't all possibly fit in my show. So here's how to find out more.
Visit the space station web at http://station.nasa.gov or visit the NASA website at http://www.nasa.gov.
Well, that's it for this time. Thanks for joining me, and we'll see you again when you meet me at the station.